So let us start with the sixth question. In the Venn diagram, shade the region P dash union with Q. So P dash means everything that is outside of P. So this is P dash. And what is Q? Q is this. So this is Q. And they are asking about union. And since this is union, include everything, all the shaded area. So the answer is all the shaded area. So it only includes that part of P which is not common with Q. Okay, so this is the correct answer. Now, part B. There are 50 students in the group. 34 have mobile phone, 39 have a computer, 5 have mobile phone and no computer. So they have given that n of m is equal to 34, n of c is equal to 39, and they have no mobile phone or no mobile computer. So intersection with c dash is equal to 5. So that means there are 50 students. So n of the universal set is 50. Okay. So now let us try to complete the Venn diagram. So what do we know now? N of m union c is given by 45. Why? Because 5 people don't have either mobile or computer. So 5 people will be here. So within these two blocks there are only 45 people. That implies n of m plus n of c minus n of m intersection c is equal to n of m union c. So if I supply the if I take all the values, 34 plus 39 minus n of m union c, m intersection c is equal to 45. So therefore m of n intersection c is equal to 34 plus 39 minus 45. So 34 minus 8, 28. 34 minus 6, 28. So 28 students have both common. And out of the entire 34 people, 28 also have computer. So this will be 6. And out of the 39, 28 are here. So this will be 11. So 5, 6, 28 and 11. Okay, so they have given a space here. So 5 comes here, not here. This completes this part. Let us move to the part C. So the Venn diagram shows the number of students in a group of 30 who have brothers, sisters or cousins. Okay, B means brothers, S means sisters and C means cousins. Write down the number of students who have brothers. So how many students have brothers? Everyone that is in the B circle will have brothers. So 2 plus 2 plus 3 plus 1. So this is 2 plus 2 plus 3 plus 1, which is 8. Write down the number of students who have cousins but do not have sisters. So let us change the color. They have cousins, that means they are in this part, but they don't have sisters. So that means we cannot include these guys and these guys. Why? Because they already have sisters. They are also part of S. So the number of students is 3 plus 8. Only these students have cousins but not sisters. So 3 plus 8. So the answer is 11. Now, third part. Find n of B union S union C whole dash. So this is the entire number of values that are outside of the circle figures. So it is 2. Only these are not included in B union C union C. Okay. Now, use set notation to describe the set of students who have both cousins. They have cousins, so C. They have sisters, so S, but do not have brothers, so P dash. So they have everything, satisfy all conditions. And so this is the intersection part. So C intersection S intersection B dash. Now, fifth question. One student is picked at random from the 30 students. Find the probability that this student has cousins. So, number of students with cousins. How many students are there? Let us count all the numbers, values in the C. 3, 1, 7 and 8. So it is 4 and 15. So 19. So therefore P of C would be equal to the total number of possible cases, which is 19, divided by the total number of cases, which is 30. So the probability required is 19 by 30. Now, sixth question. Two students are picked at random from the students who have cousins. So 19 students have cousins. Calculate the probability that both the students have brothers. So they also should have brothers. That means it should be in the place where it is common to both B and C. So only these 4 students have brothers also. And so 19 students have cousins, and out of them 4 have brothers. So what will be the probability required? The probability required is equal to all the 2 students should come from these 4. So first I am picking one student from out of these 19, and the probability to pick one of these 4 students is 4 into 19. Now there are only 18 students because I have already picked one, and there are 3 students remaining. So this is nothing but this goes in this 6 times, and this goes in this 2 times and 3 times. So this is 2 by 57. That completes the question. And let us go to the last part. One student is picked at random from the 30 students. The student has sisters. So P of A, how many students have sisters? Let us calculate. 1, 7, 5 and 2. So 7 plus 7 plus 1, 15 by 30. Which is 1 by 2. And P of B would be equal to how many students? 19 have cousins, and out of them 4 have brothers. So 15 students are there who have cousins but not brothers. So the probability would also again be 15 by 30, which is 1 by 2. So they are equally likely because the probability is the same, and so equally likely. So this looks like a lengthy problem, but it is a very simple problem. If you understand the concept of Venn diagrams, this problem is like free marks for you. Okay, so let us meet in another video. Until then, all the best.